Hello students, this is the class of units and measurements. Okay, so today our topic is units and measurements. We will start this topic and we will study further like what is unit, what are the types of units, what is physical quantity, what are the types of physical quantities, right? See, so our topic is units and measurements. As we all know, first, we know what is physical quantity. Okay. So, physical quantity is a quantity which can be measured by an instrument and which describes the law of physical world. So, we can write the quantities which can be measured by an instrument and which describes the laws of physical world. These are known as physical quantities. We can denote physical quantity by PQ. Okay. So PQ will be N into U. N we can say is numerical value of the physical quantity and U will be the unit of physical quantity. Right? So there are two things in physical quantity. First is numerical value and second is unit. Okay. So now we have different types of physical quantities. First one is there are three types of physical quantities. This is fundamental, second one is derived, and third one is supplementary. So we have three types of physical quantities. We will see one by one. Okay. Yes. So we have fundamental quantities first, second is derived physical quantities, and third is supplementary physical quantities. Firstly, we will write about fundamental quantities. That what are fundamental physical quantities? Okay. So fundamental physical quantities are those quantities which do not depend on any other physical quantity. Means they are the base quantities. So they do not depend on any other physical quantity. So these are 7 in number. 7 physical quantities are fundamental physical quantities, right? So we can write 7 physical quantities that are fundamental. So we will make a column. We will make a column here. Physical quantity means name of the physical quantity. Its SI unit, as every quantity has some unit. And next is the symbol associated with that quantity, right? So first one is length. The unit of length is meter and the symbol is m, that is meter. The second physical quantity is mass, right? And SI unit is kilograms and the symbol is kg. The next quantity that is fundamental is time. So time, SI unit is seconds and we denote it by S. Fourth fundamental quantity is temperature. Okay. So what is the unit of temperature? As we all know, Kelvin. Yes. So symbol is K. The fifth quantity is electric current. The SI unit of electric current is amperes and the symbol is A. The sixth quantity is luminous intensity. What is the unit of luminous intensity? It's candela. And symbol is CD. The last physical quantity that is fundamental is amount of substance. So amount of substance is represented by moles, as we all know. So what is the symbol of mole? MOL, right? So these are the 7 physical quantities which are fundamental. So first part is clear. Yes. Now we will write second type of quantities which are derived units or derived physical quantities. Derived physical quantities. So as the name is suggesting, derived. So derived मतलब क्या होगा? आपने भी पता ही होगा कि derived का मतलब क्या होता है कि किसी भी चीज से हम उसको derive करते हैं. तो सपोज हमारे पास जो फंडामेंटल क्वांटिटीज थी तो फंडामेंटल क्वांटिटीज से हम उनको derive कर रहे हैं. तो derived physical quantities are made up of fundamental quantities. These are made up of फंडामेंटल फिजिकल क्वांटिटीज. तो ये वाली हमारी कौन सी हो गई? डेराइव्ड फिजिकल क्वांटिटीज. आप इसका एग्जांपल्स ले सकते हो. एग्जांपल जैसे कि एरिया. एरिया क्या होता है? मीटर स्क्वायर meter square, that is length into breadth, right? So that means length into length, meter into meter, meter square. Or we can take volume. Volume is length into breadth into height. So what we can write it as meter cube. So what we are using as fundamental quantity here, this is meter square and this is meter cube. So this is length has fundamental quantity we are using here, correct? So these are derived physical quantities, right? Now third type of quantity is supplementary physical quantity. So these are fixed. There are two supplementary physical quantities. What are these two? First one is plane angle, or we can say angle. So we denote this angle by theta. Okay. So how we will denote this angle? Suppose this is arc. So if we draw an angle here and this is the radius r. So what will be the formula of theta here? Theta will be arc upon radius. This is the formula of theta. This is known as angle. So what is its unit? Unit of theta is radians. And if we can write symbol, as I told you symbol, so symbol will be RAD. This will be the symbol of radians, right? Now next is solid angle. So what is solid angle? Solid angle we can denote by d omega. Okay, so it is in 3D. Suppose we are taking one diagram, right? So if we are making it in 3D, this whole angle of 3D is known as d omega, which is the solid angle. So the distance is r and area is dA. dA is taken because of small area. So what is the formula of d omega here? It is dA divided by r square. This is the formula of solid angle. So what is its unit? Unit of solid angle is steradian. STE radians. Steradians. And what is its symbol? Symbol is SD. Right? So we have written three types of quantities. First one is fundamental quantities, which are 7. Now next is derived physical quantities. So their number is not fixed, as we have many derived physical quantities like area, volume, we can write force as well. So many quantities are there. They are made up of fundamental physical quantities. Third one is supplementary physical quantities. So their number is fixed. It is plane angle and solid angle, right? Now we come to dimensions. So what are dimensions? As we all know, what are dimensions? So dimensions are the powers to which the fundamental units are raised in order to express the derived unit of a quantity, right? Yes. So what are dimensions? The next topic is dimensions. Now we will study what are dimensions, right? So in dimensions, we can write dimensions are the powers to which the fundamental units are raised in order to express the derived unit of a quantity. Okay, so we can write dimensions in square bracket. Always we write these dimensions in square brackets. So like we have seven physical quantities that are fundamental, so we can write their dimensions. First one is length. So length is denoted by L. Second one is mass. So mass is denoted by M. Third one is time. Time is denoted by T. Next one is temperature. Temperature is denoted by K. Fifth one is electric current. Electric current is denoted by A. Sixth one is luminous intensity. Luminous intensity is denoted by CD. And last one is amount of substance. It is denoted by moles, MOL. So these are all are the dimensions of the physical quantities. In all these quantities, these three are most commonly used in deriving the formula of other quantities. Most commonly used dimensions are these, correct? So now we can find dimensions of some physical quantities, right? Now we can write dimensions of some physical quantities. How we can derive these? We can derive them one by one. Firstly, we can take area. Area is meter square, so that is L square, as meter is expressed in length. L2 is the dimension of area, or we can write it in the form of MLT M0 L2 T0, right? Next we can find volume. Volume is M cube, that means L3. What we can write? M0 L3 T0. Okay. Next we can write density. What is the formula of density? Density is mass upon volume. So we have mass dimension as M, and we have found out dimension of L. Volume is L3. So we can write M L 3 है, ऊपर जाके पावर कितनी हो जाएगी? -3. ML -3, or we can write it as M1 L -3 T0, right? Now next is velocity. Velocity is displacement upon time, right? So what is displacement upon time? Or we can say speed. So speed is meter per second, right? Yes. So what we can denote it as? Displacement is L and time is T. So we can write L T minus 1, or M0 L1 and T minus 1. Correct. Next we can write for acceleration. So acceleration is change in velocity divided by change in time. Correct. So what is change in velocity? Change in velocity is meter per second, and divided by time is second. So meter per second and second, it will be meter per second. So what will come out be? M is meter, that is length L, and T is time. So second square is T2. So it will be L T minus 2, right? Or we can write it as M0 L1 T minus 2. Correct. What we know is acceleration due to gravity. Acceleration due to gravity is same as acceleration, right? Yes or no? Yes. So we can find it like that. Now next we can see force as well. Force is mass into acceleration. Into acceleration. So mass into acceleration is mass is kg into acceleration is meter per second square. So what we can write is kg is m1 and meter per second square, that is acceleration. It will be L1 t minus 2. This is the formula of force. You should learn this formula as it is used in many questions. This is the important formula, right? We can find of other also. Work done is force into displacement, right? So what is the formula of force? ml t minus 2 into displacement. Displacement is L. So if we will combine them, L1 plus 1 is 2 and T minus 2. Correct? Next we can find of power as well. What is the formula of power? It is work done upon time. So work done is m L2 T minus 2 divided by time. Correct? So we can write it as m L2 and T minus 2 and minus 1. It will be T minus 3. This is power. Okay. So unit of work done is joules, and we can write energy as well. Energy has the same units as work done. Joules. So it has same dimension formula as work done, ml2 T minus 2. If we can write kinetic energy, it is same because energy has same dimensional formula, right? In this way, we can find dimensional formula of many quantities. We have other quantities as well. For example, frequency. It will be 1 upon time period. So it will be 1 upon t. So what is the formula? m0 L0 t minus 1. This is the formula of frequency. Similarly, we can find angular frequency also. We can find many quantities like torque. What is the formula of torque? Force into displacement, right? So force has dimensions as m1 L1 t minus 2 and displacement as L. So torque will be m L1 plus 1 is 2 and t minus 2, right? So similarly, we can find many of the quantities. Yes, we can talk of one quantity where we can write electric current. So we can write electric charge. Electric charge Q is equal to I into T, right? So I is current A amperes into T time. So we can write its dimension formula as M0 L0 A1 T1. This is the formula, right? Yes. Similarly, we can write electric potential as well. What is the formula of electric potential? V. Yes, it is W by Q. W has dimensions of ml to t minus 2, and Q is A into T, current into time. So its formula will be M1 L2, A will be minus 1 and T will be minus 3. This is the formula of electric potential, right? So there are many physical quantities of which we can find the dimension formulas. So I have given some of the values to you. Yes, one more important one is coefficient of viscosity, if you know, because we can find dimension formulas of constants also. So we can write coefficient of viscosity, right? It is eta. So we know formula F is equal to eta into A del V by del Z. So F is the force here, eta is the coefficient of viscosity, A is the area, delta V is change in velocity, and delta Z is change in distance, right? So we can write eta is equal to F into del Z divided by A into del V. So we can write dimension formulas, dimension of eta. What is the dimension formula of F? ml t minus 2, right? Delta Z is L, area is L square, and delta V is velocity, L t minus 1. So what is the dimension of eta? Finally, we can write m1. What will be the L? This L and this L will cancel out. It will be L1 minus 2. It is L minus 1, and T minus 2 plus 1. So it will be T minus 1. This is the very important formula, coefficient of viscosity. It is also used in many questions, right? Correct. So we have done with this topic. First topic in which we have studied about units, three types of units and three types of quantities we have studied. After that we have studied dimensions. What are dimensions? What are the dimensions of fundamental quantities and all these? Okay. In the next class we will study about principle of homogeneity and dimensional analysis. Okay, we will do in next class.